But I got to touch base with her tomorrow and get that figured out. Okie dokie smokies. So here we go. We are ready. We're on page 8 and we're at 6B. I can't remember if we started this one or if we were just...
No, we didn't.
No, we didn't start it. So we're right from the beginning. The directions say complete the square. Who's got a plan? Let's not do homework now. Let's be taking good notes. There's no shortcuts to good grades. It's all about hard work, determination. All right, how do we do this? Yes, Ava. Divide everything by 3. Gang, in case you forgot, when you are completing the square, that coefficient, ax squared, a, has to be 1. You cannot complete the square if there's a number in front. Okay? So we're going to get rid of that number. So we're going to divide everything by 3. So we have x squared minus 2/3 minus 7/3 equals 0. Okay? Now we're ready to do our job, complete the square. So what do we do first? Add the 7/3 to create space for a new number that's going to make this a perfect square. That's our objective. So what will that new number be? Exactly. And how did we get 1/9? Half of 2/3 is 1/3, and 1/3 squared is 1/9. Don't let the fractions freak you out. It's easier to do without a calculator. Half of 2 is 1, and 1/3 squared is 1/9. So what perfect square is this? X minus 1/3. Perfect. I gotta add these, so I'm gonna get a common denominator. Did you get 22/9? Is that okay? Now what? Square root both sides. What's the square root of x minus 1/3 squared? X minus 1/3. And then over here, please, plus or minus root 22 over 3. Is that okay when I square root that? Square to top, square to bottom. And then I'm going to add my 1/3. So x equals 1/3 plus or minus root 22 over 3. If we had solved this with the quadratic formula, the answer would have come out looking like this. That's the same thing. Would you all agree? Doesn't matter to anybody which way you write it, right? That way or this way, doesn't make a difference. All right, so we feel confident with completing the square. No. All right, solve graphically. Get those calculators out. Now we're going to do some more solving. With our calculator. So, remember last time we talked about in our second calc menu, we can either find the zeros or we can use intersections. It isn't going to make a bit of difference in the answer which way you want to do this. If you leave it like this, you're going to solve it with intersections. If you want to do zeros, you're going to have to rewrite your equation like that. Does that make sense to everybody? Okay, we got option A, option B. How do you want to do it? Loudest kid wins.
B.
B?
B. A. A. B.
Alright, we're gonna do a B. We're gonna solve it with zeros, okay? If you wanna solve it with intersections, go right ahead. You'll get the same answer as us, it won't matter. Okay, so, oh, that's an absolute value. So I have to learn how to put that into my calculator, right? Alright, so let's go to math. A math button, right there, math, we're gonna find it. And then across the top, you see math, number, complex, probability. We want NUM, and the very first option there is absolute value. So press that, and then type in what's in there, which is 2x minus 3, close the parentheses, and then minus x squared. Oh, wait a second. Did you go to y equals? Remember, if you're going to graph it, you got to be in y equals. So, oops, if you didn't, you need to go back to y equals. And then type in math, go over 1 to number, NUM, absolute value, 2x minus 3, and minus x squared. And hit graph. I don't even know how to describe that. It's kind of a
Gravel or bump.
yeah,
A rock.
I don't know, like that sort of thing. Because, guys, what's happening here? You are graphing, what shape is this? A V? What shape is this? A U, a parabola. So you're putting them all into one equation, so you're getting kind of a UEV, which is kind of what we got here. What are we looking for? That point and that one? So let's find them like we did last week. Second calc 0. Wow, I got -3. That's crazy. Yeah. I must have copied that out of the book. Because that never happens when I make them up. I didn't get 0. I got, yep, I got 1. So x equals -3 and x equals 1 are the two solutions to the equation. So where do we find our absolute value? Our absolute value is in math, and then the NUM option, the number option. Okay. All right, what's next?
Oh my god.
Okay, how do you want to do this guy? Since we did that one with zeros, let's do this one with intersections. You can do them all the same way. It doesn't matter. However you want to do it, we'll practice intersections here.
What if like the thing's not, if you're trying to find a 0, what if it doesn't intersect?
In here,
Yeah, like what if it doesn't intersect?
the x-axis. Okay, then there wouldn't be any zeros. There would be no real zeros. So that happens a lot. Like you could have a 4th degree equation that would look like this. It has no real zeros. It would have 4 imaginary zeros, but no real zeros. Okay.
What's an
Like,
imaginary 0?
X squared plus 9, x squared plus 4. So that would be x to the 4th plus 13x squared plus 36. If you graph that on your calculator, it'll work like this. It has no real zeros. They're all going to be imaginary.
That sounds like so fake. Yeah.
All right, so I'm going to graph this with intersections. So I'll put in the square root. Everybody know how to put in a square root. Make sure you close the parentheses. So this is 1. And then negative, and when you do negative, make sure you're using your negative button, not your minus. You gotta use your negative button. Negative x squared. And so where's your calculator?
Yeah, I did. I forgot it.
Did you forget your phone today?
No, I have my phone.
Yeah, you have your phone.
He never
Of course you
forgets
have
his
your
phone. He's an addict.
Because your phone's important to you.
The calculator is.
My
Your
calculator is
calculator
also
has to be
important.
He's been
important
relying on
to you.
me. I'm sorry. Gotta let him out into the free world eventually.
Now, I'm not
Stand on
kidding,
something.
we need our calculators, okay? Alright, so, remember, the AP exam has 4 sections and 2 of them are calculator. You gotta know how to use it. Alright, so everybody good, got it in? Alright, I'm gonna hit graph and see what happens. Now, my window, I don't know how your window's set. I just changed my window a little bit, and I got something that looks like this, and like this. Is that what yours looks like?
Yeah.
So the points of intersection would be here and here. All right, let's find it. So second calc, intersect if you're doing it this way. Cursor on both sides of the point in question. Oh, this one didn't come out nice. Negative 1.638. Let me know if you agree with that. Okay. And this one, I got 1.447. Is that okay with everybody? Let's talk about this for just a quick second. Does that make sense to you, that parabola opening down like that, in terms of what you put into the calculator? Does that make sense? Yeah, because x squareds are parabolas. A negative out in front turns it upside down. So that makes perfect sense. This thing right here, does that make sense to you at all? What about that makes sense? Yep.
Because it's +7, so it would go over negative.
Exactly. X, this picture has to start at -7, because what happens if you put in something before -7? It would be imaginary, right? So its domain is from -7 on. Very good. Any idea why it has that shape? Or did you just memorize that last year? I hope you did. That's the square root function. But why does it look like that, Alex?
Because if it's like half of the parabola.
Yeah, it's the inverse of an up and down parabola is one opening sideways. But to keep it a function, we can't have the bottom half, we can only have the top half. Very, very good, that's right. Okay, are we all set with that? All right, 2 more problems, and then we're entering into the world of imaginaries. This one's easy. Solve with the quadratic formula. Y'all should be able to do that. We had the formula on the board the other day, but you should have it memorized. go ahead and solve it with the quadratic formula. I knew you were gonna do it. This one, what would you come up with this?
1 plus or minus radical 22 over 3.
Just wait and see if anybody else gets that. I think he did some simplifying there. What was the step right before this? There should have been a step before.
It was, I had 2 plus or minus 2 radical 22 over 6. Or, yeah.
Yeah. So when he just cranked stuff into the formula, this is what he got. Then he recognized that root 88 breaks down into 2 root 22. And then he recognized that he could cancel out a 2, a 2, and a 2. And that's how he ended up with that. Which is exactly what we got. The very first problem we did today. We completed the square on that equation. And that is exactly the same answer we got, only it looked like this. But it was the same thing. Anybody have a question about that? You feel like you got that under control? Quadratic formula is like, okay, yeah, pretty easy. All right, what's happening here? Number 9, height of a ladder. All right, what is John doing? All right, so here's the building, here's the ground, here's the ladder. The ladder is 18 feet long. Does that make sense to everybody? When the 18 goes there, this is the ladder. The distance from the ground to the top is 5 feet more than the distance from the building to the base of the ladder. So if this is x, what would this have to be? X plus 5. In this position, how far up the building does the ladder reach?
How far up the building is the ladder reach? 5 feet more than the.
5 more than this, yeah, but I don't know what that is.
It's gonna be a squared plus b squared equals c squared.
Oh, the man with no calculator says, at least I remember my Pythagorean theorem, right?
Indeed.
So the Pythagorean theorem says x squared plus x plus 5 squared equals 18 squared. Would you agree with that?
Yeah.
So x squared plus, don't make an algebra 1 mistake. That's a FOIL. You gotta FOIL that. So x squared plus 10x plus 25 equals 324. I did memorize those at one point.
Yeah, that's right.
Is that right? What a mess. What do you want to do?
I don't want to do it at all.
Well, that's not an option.
You just fold.
What? We already did that.
No, you got like,
I didn't see you were up there.
Simplify this character. Add like terms and then point back.
Combine like terms, so 2x squared plus 10x minus 299, yuck, 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 equals 0.
Quadratic.
Then I could use the quadratic formula, or I could complete the square, or I could graph it on my calculator, right? So remember, if it's a calculator active part part of the test, you have that option, all right? If it's a no calculator part of the test, then you don't have that option. So let's go ahead and solve it algebraically. I don't think I want to complete the square, do you? I just erase my picture,
It's a little
which is a
tough.
good idea.
Take forever.
Yeah, it's gonna be yucky, because it's gonna be full of fractions. So x equals negative b plus or minus the square root of b squared minus 4. Well, I'm still gonna type this in because those numbers are too big for my feeble brain to handle. Negative b plus or minus the square root of b squared minus 4ac. Where do we have it there? Did you get 2492 under here?
Yeah.
Now remember, this was X, right? I'm gonna get two answers here, but one of them is not going to be acceptable, because one of them's gonna be negative. So I'm just gonna find my positive one, negative 10 plus the square root of that. I'll divide by 4. I came up with X being 9.80. Did I do that right? But what was the question again? How far up the building? So I'm gonna add 5 to that, and the answer would be 14.80 feet. Avery, back in the day, I had the coolest sign ever, hung up by the clock that you were just looking at, and it said, "Time will pass, will you?" But then I thought it was cool and funny and nice. Admin made me take it down because it hurt your self-esteem.
I find it funny. Yeah,
I find it funny too, but now I'm just going to scold you. So you have to take it off. You're going to have to leave soon enough. Enjoy every minute of your favorite period of the day. I know it's after lunch, I know it's a long afternoon, but,
Monday too.
and it is a Monday. Although by now it doesn't feel like Monday. Monday only feels like Monday like during now. After that, it is.
Just bro, your hand.
I know.
Equal complex numbers. Mr. Art, sit up. What are equal complex numbers?
So much.
The definition is actually quite simple, but we use it sometimes in solving problems, so we kind of have to understand how it works. If a plus bi, that's a complex number, a plus bi, or x plus yi, whatever letters you want to use, equals c plus di. If these two numbers are equal, then what do you think must be the case?
A equals C.
Yes, very good. Then A has to equal C and B has to equal D. Doesn't that make sense? That their real parts have to match, these are their real parts, and their imaginary parts have to match if they're going to be equal to each other. That's the only way. I'm gonna name it Z, because that's what your book does, or what our book does. You can name anything you want, but if Z is this number, this is Z. Then the conjugate of Z, which is written with a bar over the top, we call that Z bar. That's the conjugate of Z, would be what? What's the conjugate? You know this. What's the conjugate of 2 plus 3i? 2 minus minus 3i? You guys know that, that's the conjugate relationship. And then powers of I, which except for the first couple are really not, I mean, they're just math, it's just a math problem after that. You don't really run into these very often. But you probably learned them last year. I is just I. By definition, it's the square root of negative 1, but I is just I, okay. What about I squared then? Not 1, negative 1. Because it's the square root of negative 1 times the square root of negative 1. So it would just be negative 1. How about I cubed then? Negative I, because it would be these two times each other. I cubed would be negative I, perfect. And what about I to the 4th? That, oh, not 0, oh, no, not 0. That would be 1. Because isn't I to the 4th, I squared times I squared?
Yeah.
So negative 1 times negative 1. Now, could we keep going? Absolutely. I to the 5th, 6th, 7th, 253rd. We could just keep going. But, do you remember what happens? What happens when we keep going? It just repeats because every 4 i's just make 1. And so we can kind of just forget them. This would be I to the 4th times I, but since that's just 1, it's just going to be I. And then I to the 6th would be negative 1, and so on and so on and so on. Well, what do you do if you have I to the 573rd?
Divide by 4 and take the remainder.
Divide by 4 and look at only the remainder. Because, if I divide correctly here, I get 143 groups of 4. That means 1 times 1 times 1 times 1, 143 times. And then the leftover is 1. So the answer would be just either the first or mine. Good job, Mrs. Coors would be very proud of you.
I miss her so much.
I tried to say hi.
Yeah. Oh, that is so
She's cool.
A wonderful person. Okay.
Blame Cooper. Blame Cooper.
Her song? Yeah.
We still got Miss Hollis.
I had her for my J3. She was awesome.
Mrs. Hollis.
Video notes. Oh, Mrs. Hollis is the
Video
goat.
notes, bro. Oh
All
my
right,
God.
so now
I
we're
love her
going
strategy.
to do number
What,
2.
not work at all.
Sometimes just homework in class and class at home. Is that actually what she does? She's too busy coughing.
All right, so these are 2 complex numbers, and again, I've named them the way your book names them. And I know we don't use a book, but if we did, this is the way they're named in the textbook that we're kind of working from. So, you can name them anything you want. Z sub 1, Z sub 2, these are my 2 complex numbers. I'm gonna add them together. What do you think that's gonna be? 5 minus 2i. Collect my terms, basically. How about this one? Z sub 1 minus 2 Z sub 2. That would be 2 plus 3i. That's this. And then minus 2 of those. So regular arithmetic will distribute negative 6 plus 10i. Negative 4 plus 13i. Is that what you got?
Yeah. You mean
3z1s times z sub 2. Three z1s would be 6 plus 9i. 3 of these. And then times z2. How am I going to do that? Foil. So first, outside, inside, last. Tell me about this.
Just
Plus 45, plus 45, 63 altogether then, if I add 45 here, minus 3i. This is really easy. All right, number 4, what's happening here? We're doing 2 plus 3i over 3 minus 5i.
Don't you have to multiply
The conjugate, absolutely. This is where we use the conjugate, guys. We gotta multiply by 3 plus 5i. Why are we doing this? What is going to happen? To get rid of the I on the bottom? Why can't we have an I on the bottom? Because it's a radical? And we don't want radicals on the bottom. So, foil, foil, foil all over the place. 6. And with the conjugate, this will always happen. The outsides and insides of the foil will disappear if they're conjugates. Once again, we've got this I squared, so this will be negative 15. So negative 9 plus 19i. This will be plus 25. All right, check my arithmetic. Is that what you got?
Yeah.
These are the kind you might remember. Sometimes you can simplify this one, obviously you can't. But if you had negative 8 plus 3i over 16, you still can't, right? No simplifying. The only way you can simplify is if all 3 numbers can reduce. So here, I could take out a 2. This, don't try canceling that. That doesn't cancel. No, it's there. Cancels there. Okay? All right, here we go. Now we got some easy problems to do. Go ahead and do A. Compare answers with your partner. That's going to be a foil again. hear some chatting, which is good, good, good. Are we chatting about this? Is this right or wrong? Did I make a mistake up here with my arithmetic somewhere? Scout, this is what you guys came up with? Ben, what about you and Fred? Is this what you're getting here when you foiled that out? Did you end up with this?
Yeah.
For real? Okay. Let's look at the next one, because this one sometimes causes us problems. There is an order of operations with complex numbers. And I know that if you were walking down the hall and you found root 3 times root 8, you could multiply those and get root 24. 100%. You could do that. But as soon as the radical, this guy right here, is negative, you can't do that. When you have a negative under a radical, the first step must be to pull out the I. That's how we start. So this becomes I root 3 times I root 8. Now you can go ahead and multiply these and get root 24, but now you also have an I squared. This is going to be negative, I squared. So it's going to be negative 2 root 6 is your answer. If the radicand is negative, you must pull the I out first. Step 1, pull the I out. Then do whatever else needs to be done. Okay, so when you look at the next problem, that I should not be under, we don't have to do that yet. So the I is not under that radical. That's my fault, it looks like it is.
Is it multiplied?
Yeah, it's root negative 8 times I, yeah. Now, can we find the square root of I? Absolutely we can, but not yet, we haven't learned how to do that yet. That requires trigonometry. Okay. So this is just root 7 minus 1. Would you agree with that? Minus 6 plus the square root of negative 8. I'm going to put that I in front. Now, what's going to happen to this right here? That's going to become, you already have an I, and now you're going to have another I. So you're going to have I squared, which is going to make this thing negative again. These two can be added. So I have root 7 minus 7 minus 2 root 2. Now there's a lot of places to get lost in that mess. Are we okay? Oh boy. D is a mess. All right. Directions say simplify or something. Yeah, simplify. So what do you think? Foil the top. You do that. So that will be when I foil a 6 7 minus I, keep an eye on that, did I do that right? 7, because this is gonna become plus 1. Confirm. Now what?
Multiply by 5 minus 2.
Conjugate, yep, 5 minus 2I, let's remember that word, 5 minus 2I, conjugate. Foil again. And ready for my final answer. I think, which is what? 33 minus 19I over 29? Yes. Not a hard problem, it's kind of tedious. Last one in P6, so this is gonna be due on Wednesday also. Right, 5 minus 2I minus 7 equals x minus which plus yi. All these parentheses make me nervous, so I'm gonna get rid of them. Is that okay with you? Just do that. Need somebody to have an idea. Well, I can definitely clean this up, so negative 2 minus 2I really isn't much I can do here. Alex?
Would you move the negative 3 over to the other side so that you can do the equal complex numbers? Get them.
You wouldn't even have to do that, but you absolutely can. He says, I'm just gonna move this 3 over here and make this 1 minus 2I equals x minus yi. Does that make sense to everybody? You don't have to do that, but that's definitely doable at 3. And then he said, look, these complex numbers are equal. And what do we know about equal complex numbers? The parts without the i's have to be equal. So what is x? 1. The parts with the i's have to be equal. So what is y? 2. Done. How easy is that?
Not very.
Yeah, it is. Yeah, it is.
I see practice.
All right, we're gonna do a couple more problems and I'll be still. Take a look at P7, which is all about solving inequalities. What's your thought?
Once you split it into, so it'd be negative x plus 3 and x plus 3 each pair of pieces.
Can you say that again?
Once you split it into 2,
You absolutely can. So one option is to say x plus 3 is greater than or equal to 6. So just write it the way it is. And then x plus 3 is less than or equal to negative 6. And you need to have a word, if you're going to do it this way, you need to have a word in there. The word is or, that's a greater than. So then you would solve, and it looks like x is greater than or equal to 3, or x is less than or equal to negative 9. So our answer would be everything from negative infinity to negative 9, or everything from 3 to infinity. That's a little confusing. Remember, you can put this on the number line. Whoops. There's a bracket somewhere. So that would be our answer, written as an interval, because that's how you write your answers. Okay? Now, I can't remember if we've talked about this or not, but I want you to at least be open to doing this on the number line as a distance. This, if I'm doing it on the number line, that has to be a subtraction. So this says the distance between x and negative 3. So here's negative 3. The distance between x and negative 3 is more than 6. So if I go out 6 this way, I'm at 3. And if I go 6 this way, I'm at negative 9. And I want the distance to be more than 6. So there's my answer. No algebra involved, and it's kind of the calculus way of thinking about absolute value. So, think about on your number line. If this is 5 and this is 7, and I say how far apart are they, you would say 2. 7 minus 5. If I'm thinking about my absolute values as a distance, this has to be a subtraction. I don't say 7 plus 5, but I say 7 minus 5. So the distance between some number and negative 3 is more than 6. Count 6 this way, 6 this way, and I'm done. This is the answer no matter which way you do it, but I want you to be open to that, and I'm open to it. Alright, so let's look at the last one, or actually, we don't have time to do it. So, we'll stop there. P6 is due Wednesday, that'll be